Okay, students. Now let us discuss another important model in Coulomb's law of equilibrium charges. Right. Here, read the problem first. Three charges of equal magnitude Q are placed at the vertices of an equilateral triangle of side L. In earlier class, we discussed about a square. Now we discuss about equilateral triangle. Equilibrium of charges in equilateral triangle of side L. How the system of charges can be placed in equilibrium. How the system of charges placed in equilibrium. Right. That means here this is a triangle, equilateral triangle. Equilateral triangle. There are three charges placed at the corners, vertices of the equilateral triangle. Let us give the numbers 1, 2 and 3. If we place another charge at the centroid, then these charges are in equilibrium. Otherwise, they are not in equilibrium. That charge must be negative. The charge must be negative. So, we want to find out what is that charge. What is that charge? So, that is we are going to discuss. First of all, let us take one charge. Before that, this is a median and this is another median and this is median. The intersection point of these three medians is nothing but centroid. That is centroid. Now here we will place a negative charge. Then only the system of charges are in equilibrium. Otherwise, they are not in equilibrium. Now, let us calculate force acting on 1 due to this second charge. Repulsion force. For example, if the charge is moved towards second charge, that is the repulsion force. It repelled this charge. This is F12. Now, force acting on the first charge due to this charge, that is equal to, that is F13. F13. Okay? Right. What is here? F13 and F12, let us calculate. Okay? F12 is equal to, what is the formula? Here the side length is nothing but L. Side length is nothing but L. 1 by 4 pi epsilon naught Q into Q square divided by L square. Next, F13 is equal to 1 by 4 pi epsilon naught Q into Q square by L square. These two forces are equal in magnitude. They are acting in different directions. Let us assume this is F and this is F. Okay. Exactly. Then what happens here? This is the resultant force. This is the resultant force. It bisects. Okay. This is F. And this is also F. F and F. So, here this is the resultant force, Fr is equal to, we split this Fr into two components. This is, that is nothing but this is 30 degrees. And this is also 30 degrees. This is 60 degrees. Okay, in equilateral triangle, every angle is 60 degrees. So, this is F cos theta along this direction, F cos theta along this direction. F cos theta. This F sin theta and this F sin theta are cancelled. So F resultant is equal to how much here? Cos components are added. They are in same direction. They are in same direction. That means 2F cos theta. 2F cos theta. Fr is equal to 2F. Theta means 30 degrees. Okay. Theta means how much? 30 degrees. Cos 30. So Fr is equal to 2 into F means what here? 1 by 4 pi epsilon naught q square by L square. Cos 30 is equal to how much? Root 3 by 2. Cos 30 is equal to how much? Root 3 by 2. So this is the resultant force. This is the resultant force. Right. Here 2 gets cancelled. 2 gets cancelled. F resultant is equal to root 3 into 1 by 4 pi epsilon naught q square by L square. This is the resultant force acting on charge 1 due to the 2 and 3. Equation 1. Right. If this resultant force is balanced by another force which is acting in opposite direction due to the charge present at centroid, that is negative charge, then this charge is in equilibrium. Likewise, second charge is also in equilibrium, third charge is also in equilibrium. Right. Now, F resultant is balanced by the F1 force acting on the charge 1 due to negative charge which is placed at the centroid O. So Fr, that is equal to root 3 into 1 by 4 pi epsilon naught q square by L square. That is equal to here, what is the charge here? Negative charge. So we need not to put negative sign while calculating the force, electrostatic force acting between the two charges. 1 by 4 pi epsilon naught. Okay. Q into Q, how much? Q square by, what is this distance here? What is this distance? So here this is L and this is L by 2. Okay. And this is the right angle triangle. That means this side, calculate this side, that is root 3 by 2L. Root 3 by 2L, this side. The centroid divides this side in 2:1 ratio. 2:1 ratio. That means this is 2 parts and this is 1 part. 2:1 ratio. That means here how can we calculate this side here? This part has 2 and total parts 3. Total length of this side is root 3 by 2 into L. That is equal to how much here? L by root 3. L by root 3. L by root 3. So this side is nothing but what? L by root 3. Right. L by root 3 whole square. L by root 3 whole square. So we get here root 3 into 1 by 4 pi epsilon naught q square by L square is equal to 1 by 4 pi epsilon naught, this root 3 whole square. That means here q square by L square into this is 3. This is 3. Now, here we put here capital Q, that is capital minus capital Q. That is we write here small q into capital Q, small q into capital Q. Here we place the third charge at the centroid is capital Q, that is minus Q, minus capital Q. Right, here 1 by 4 epsilon, 1 by 4 epsilon cancel. This Q goes Q times L square cancel. What we get here? Root 3Q is equal to root 3Q is equal to root 3Q is equal to this 3 comes to the numerator 3Q. So we want to find out capital Q. That means charge is placed at the centroid. Charge is placed at the centroid. So Q is equal to what we get here? Root 3 q by 3. So q is equal to q by root 3. This is charge must be negative. So your answer is q is equal to minus q by root 3. So here finally to keep the system of charges in equilibrium we must place capital Q is equal to minus q by root 3 at the centroid. So this is the problem based on the equilibrium of charges. First, how we can solve this problem? Force acting on the first charge due to second charge, calculate. Force acting on the first charge due to second charge, calculate. These two forces are acting different directions. The angle between these two forces is nothing but 60 degrees. The resultant force bisects these two forces 30-30. Now split these resultant forces on the principle of vector resolution. Then we get a cos component and sin component. Sin components are cancelled, cos components are in same direction. So that resultant force is equal to how much? Fr is equal to F cos 30. Cos 30 is equal to root 3 by 2. Fr is equal to what we get here? Root 3 into 1 by 4 epsilon q square by L square. So this force is acting along this direction. This force is balanced by another force which is acting in opposite direction due to the presence of charge minus q and capital Q at O. Then all the system of charges are kept in equilibrium. So here F resultant force is equal to F1O. That means here root 3 1 by 4 epsilon q square by L square, that is equal to 1 by 4 epsilon naught. Here this is small q and this is capital Q. Small q into capital Q divided by this distance is nothing but how much? L by root 3 whole square. How we calculate that L by root 3? This is equilateral triangle. Total length of this median is nothing but root 3 by 2L. This median is divided by the centroid in 2:1 ratio. So this is the 2 parts and this is 1 part. 2 by 3. 2 means 2 parts divided by number of parts by total parts, that is equal to 3 into length of the side, root 3 by 2 into L. So we can calculate L as L by root 3. So L by root 3 whole square. This root 3 whole square means what? 3. This 3 comes to the numerator. Okay. Into small q into capital Q divided by here L square. Here we cancel. On doing the calculation, we get root 3 q is equal to 3 into capital Q. Capital Q means what? The charge we place at the centroid of the triangle. So q is equal to, we get q by root 3. But this charge must be negative. Then only these system of charges are in equilibrium. Otherwise, they are not in equilibrium. Okay. So to keep the system of charged particles in equilibrium, we must place q is equal to minus q by root 3 as the centroid. Okay. This is the problem.